Comparison test. We start with a solution of 250 milliliters of water and 2 drops of standard inkjet ink, which is believed to have an average particle size of about 5 nanometers. The test device consists of a 10 milliliter syringe connected to a pressure gauge and filter assembly designed to hold a 25 milliliter filter disc. First, we fill a sample cup with a control sample of the unfiltered solution. Our first test is conducted using a 0.025 micron polymeric membrane as the filter media. As the test begins, we can see that the pressure required for filtration is at the 4 bar or 60 psi limit of the pressure gauge. Since the particles of ink are smaller than the pores in the membrane, most of them pass right through with little change to the color of the solution. When the membrane disc is removed, we can see the membrane is only slightly darker in color since it removed only those particles larger than 0.025 microns. Our second test uses a 0.1 micron charged membrane filter. Due to the charge, you can see that initially it filters out the ink particles very well. However, as the active charge sites become saturated, there is complete bypass of the particles through the 0.1 micron pore in the membrane. The pressure drop at 1.5 bar, or about 30 psi, is much lower than the previous membrane with a correspondingly higher flow rate. When this membrane disc is removed, we can see this membrane was much more effective in removing the ink particles, up until saturation of the charged attachment sites. Our last test, with its 2 micron pore size, the differential pressure is much less than 1/2 bar, or about 3 psi. As you can see, it is absorbing all the visible particles. When the filter is removed, we can see that the ink particles have been trapped inside the media. With over 500 square meters of surface area per gram of nano-alumina fibers, the media still has much more filtration life remaining.